Lesson P.7, solving inequalities algebraically and graphically. So we've solved some equations, now we've got to review our solving inequalities. The algebraic part, that's pretty much review. The graphic part is a little bit, that's more the newer piece, because you've solved inequalities graphically, but this is more solving like a quadratic inequality graphically. So, at the top, as we are looking at this, we're first going to talk about absolute value inequalities, because we're talking about absolute value inequalities and then quadratic inequalities, I think are the two big things if I recall. In an absolute value inequality, remember what's inside an absolute value could be positive or could be negative. It could have either value inside. And so with that in mind, we have to set up two statements when we do this. Just like if we saw absolute value equations, we have to set up two statements. So if you start with a less than sign, okay, if you start with a less than sign, then it becomes an and inequality. So if it's a less than sign, you use the and symbol. There's a cricket back there, something isn't there. I heard it during first hour. I was like, oh, that's obnoxious.
Okay, I don't hear anything. Are you guys?
It stopped. It'll be back probably.
Wait,
It was brief.
We should catch it.
Okay, so I always, when I say my less than, I use that as kind of my less than, you know, less than with a D on the end, less than. So when it's a less than sign, you're going to have an and in the middle. And so you're going to set it up as the given equality, so U less than A, and then there's always two things you change. You change the less than to a greater than, and you change the positive value to a negative value. So there's always two pieces to change here. The other option, if you have a greater than sign, if you have a greater than sign, we're going to have an or statement. And are you catching how I'm saying that one? Greater. Okay. So you can have less than, and it's an and statement. Greater than, and it's an or statement. Okay? You do the same thing though. You keep the first inequality. So in this case it'd be U greater than A. Use the word or, and then you keep the U. Greater than switches to less than, so you switch the inequality sign, and positive A switches to negative A, or you do the opposite sign. Remember with an and statement, what do and statements usually look like once we shade them? We had and statements and or statements. Dig deep in those Algebra 2 brains, do we remember?
Didn't they go together? Or no, they went out.
Well, which one switched?
Because
One of them you're shading in the middle, and the other one you're shading out from the piece point.
Or is in the middle, and's on that side.
No.
Well, it has 50-50, guys.
Okay. So with an and statement, it is the intersection. And so it is the intersection of where they overlap. So you end up, most of the time, the and shading is in the middle. An or statement is the union. So you're just shading whatever it tells you to shade, which usually is going left and right from the points. Okay? Okay, let's review. Let's look at example 1. Absolute value of x minus 4 is, what symbol is that? Less than 8.
Less than.
Okay, so what's my first inequality I'm going to write?
Yeah.
X minus 4, less than 8. You keep the inequality as is, drop off the absolute value bars. What word are we going to use? This is going to be an and statement. And it's an and statement because that is a less than sign. What about my second inequality? How does it read? Still x minus 4. Then what? Yeah, less than becomes greater than. Positive 8 becomes negative 8.
This makes sense.
Okay? And then we solve, yes?
Yeah.
If it's x minus 4, I'm going to add 4. So x is less than 12. And if it's x minus 4 over here, we're going to add 4. x is greater than -4. Traditionally, with and statements, we don't leave our answer like this. Okay, with and statements, we don't leave our answer. This is one where and statements, we combine them into a compound inequality. X in the middle. Easiest way for me to teach is I say larger number on the right, smaller number on the left. So I have -4, then x and 12, and the appropriate signs in between. X less than 12, x less than 12. This was x greater than -4, but my x and -4 are flipped, so it is less than. Okay? I always say with an and statement, as long as you have the bigger number up to the right, the smaller number to the left, these will both appear to be less than signs when you put them in here. Okay? I know if you flip this one, it's great, but they both are less than signs when you write. Now, that's one way to express your answer. That's what I thought. I have an interval notation in my notes. Okay? We've got to practice that interval notation. Okay? Here, let's do the graph first. Then you can tell me the interval notation. On the graph, okay, there's me counting by twos. I don't know. Get -4 and 12 on there, yes? How do we graph this? If you look up here, x less than 12 says we go where?
To the left.
To the left of 12. And what are we going to have on 12? Parenthesis. X greater than -4 says we go where?
To the right.
To the right of -4. And what are we going to have on -4? Parenthesis. And this is what a traditional and statement looks like. My shading is between -4 and 12, just like x is between -4 and 12. Interval notation? Looks like an ordered pair, but it's not. Correct? Okay. Questions there? Okay. So that was an example of a less than signed an and statement going from there. Example 2. Thoughts on example 2?
Add 3 to
And it's not that we couldn't distribute the 2 into the absolute value. We don't traditionally do that a lot. That would be doable. But there is a step that definitely has to be done before we can move into setting up the 2 equations, or 2 inequalities, excuse me. And that is, traditionally what we talk about here is getting the absolute value by itself before we get started. So if we're going to get this by itself, think about the absolute value of 3x minus 2 kind of being your variable. What needs to move? The 2 out front and the minus 3. So how do we move the minus 3? We're going to add 3. So I'm going to say 2, absolute value of 3x minus 2, greater than or equal to 10. Divide by 2. If we divide both sides by 2, we end up with absolute value of 3x minus 2 greater than or equal to 5. Now what? Okay, now we're going to set up 2. It's absolute value. We're going to set up 2. The first one's pretty much always the given one. 3x minus 2 greater than or equal to 5. What's my word? It's a great or than statement, so or. What's my second inequality? Okay. 3x minus 2 less than or equal to negative 5. Change the inequality sign, change the sign on the number. You know how to solve these? If it's 3x minus 2, I'm going to add 2. 3x greater than or equal to 7. X greater than or equal to 7/3. It agrees with my answer key. Carry down the word or. And we add 2 over here. 3x less than or equal to negative 3. Divide by 3. X is less than or equal to negative 1. Now, with an or statement. Friendly reminder, this is an or statement for inequality. You cannot put it together like you have to do an and statement. An and statement gets written as one joint compound inequality. The or statement stays as 2 separate inequalities. Okay? Now, as we look at a graph, -2, -1, 0, 1, 2. Where is 7/3?
Something. Well, that's
7/3 would be what?
2 is 2.
2 and 1/3. I kind of goofed, didn't I? If you want my honesty, my brain briefly said 1 and 1/3. And so at the time I was making my graph, I thought, oh, if I make up to 2, I'm good. Okay. And then as I was asking you guys that question, I was like, oh no, I didn't make my graph far enough, really. Okay, so 7/3 is going to be about 2 and 1/3, right? What are we doing? If it's x greater than or equal to 7/3, you're going to make a bracket and you're going to shade to the right. X less than or equal to -1. What are we doing there? Less than or equal to, you're shading to the left, and it's a bracket. Remember, the bracket in parentheses open towards wherever the shading is. What about interval notation? Okay, if we look at the left side of our graph, shading starts here at the left arrow. Negative infinity, which always uses a parenthesis. Negative infinity to what? -1 with a bracket. Official appropriate, notation for the or, we use a union symbol, which kind of looks like a U basically. And then our next one, 7/3 with a bracket to infinity. Okay. Ready? That's your absolute value, inequality review. You're doing those by hand. Just remember your rules. Now we're going to look at solving quadratic inequalities. So this is probably a little bit newer. I'm trying to think if we solved quadratic inequalities at all in Algebra 2 or not last year. And I don't necessarily think we did. I think we did more the linear, absolute value. Yes, I think we did those. I'm not sure we did quadratic. So that's where I say I think this is a little bit newer. Quadratic inequality is first solved by solving the quadratic equation equal to 0. And then it's going to give us our two solutions. We're going to use our graphing calculator to check and see which numbers would be greater or less than the numbers we solve for. And we can talk about ways to do this with or without the graphing calculator. Okay, so it's not that you have to use a graphing calculator on this one, but you can. So as we work to solve this quadratic equation. Okay, in other words, setting it equal to 0. We're solving it because that's going to give us our solutions. We just then have to figure out less than or greater than part. So think about the equation. X squared minus x minus 12 equals 0. What are my options for solving that? Quadratic formula, factor, both technically work, yes. I personally, x squared minus x minus 12, I'm going to go for the factor form. If I factor this, x squared breaks down into x and x. Multiplying to be negative 12 and adding to be the negative 1, yes? So if it multiplies to be negative, we need a negative. If it adds to be negative, larger value is negative. So x minus 4 and x plus 3. We didn't do any of that basic factoring the other day, did we? We jumped right to the hard stuff. So I don't know, maybe that was a good review on the basic factoring for some of us. How do we solve this once we factor? Okay, set each part equal to 0. So either x minus 4 equals 0 or x plus 3 equals 0. So that gives me solutions of 4 or negative 3. Okay, so those are the solutions we're going to use in our problem. Now, the key is, where is our answer in relation to the 4 and negative 3? Is our solution greater than 4 or less than 4? Is it greater than negative 3 or less than negative 3? Like, those are the pieces we have to look at here. Now, in the directions, it did suggest that we could use the graphing calculator to figure this out. Okay, 4 and negative 3 are the values that we'll be referencing there. And so, in order to use the graphing calculator, we're going to have to what? Take this and graph it. What are you putting into the graphing calculator? Yeah, y equals x squared minus x minus 12. So we're going to graph that.
Would you be able to find the x-intercept? The x's by also just graphing it.
And we'll talk about that. Hold on. We'll talk about that in another example or two. And this is where I'm trying to work you up to that. But there is definitely, yeah, there's ones we'll have to do that on. So we're going to graph that. And then after we graph it, and I know you guys are already working on the graph, but how do we know where our solutions are? That's what we have to think about. So, let me see. You know what? I don't even need to graph this on the calculator. You guys can graph this on the calculator, right? I mean, I have it in my notes, and I can just tell by looking at this what it does. Because x equals 4 and x equals negative 3, are you figuring out what those are? Those are my x-intercepts, yes? Those are my zeros. And so I'm going to sketch a graph right over here. I was trying to decide if I had room. I think I can make it happen. So when I found that 4 and that negative 3, I know it crosses, my graph crosses through the x-intercept there. What shape is this graph? It's a parabola, yes. And is it a right side up parabola or upside down parabola?
Right side up.
Right side up. I'm just trying to get it so you can see all of it. I say, you don't have to be able to see all of it. Is it going off
It was like off-centered. It was like all the way over here, and I was like, I don't want that.
Okay, so always go, if you do zoom and 6 standard, that would always take you, now Mario might have it zoomed out a little bit more than that,
No,
but that takes you, yeah.
You could see it though.
I mean, it's centered. And here's the deal, guys. We can see what we need to see if it's going off the bottom of your graph. Now,
I've already bugged me.
it was
there,
off-centered,
and I
so-
couldn't even see what.
Yeah, so do your Zoom 6, go back to a standard screen. That would be my helpful hints there.
Or I just hand it to Mario and he fixes it for me. That's pretty cool.
You've got to learn because you can't hand your calculator to him on a test because I'm going to pull both your tests and say, no way. So,
I don't know.
That's okay.
okay, so you have a parabola. And what did you notice about this parabola?
It's very huge.
It's very U-shaped.
Drops through -3 and 4.
Okay, it's specifically going through the x-axis at -3 and 4, correct? Because those are the solutions to the corresponding equation. Now, what is our question that we're being asked? So if you go back to the original problem, we are trying to figure out when is x squared minus x minus 12 what?
Greater than 0.
Greater than 0. So what does greater than 0 mean? On this graph, I want to know where my graph is what? Where is it greater than 0? Where it is above the x-axis.
Yeah.
Okay, so that's the question. Because it says greater than 0, we're trying to figure out where is this graph above the x-axis, because we basically want to know where are the y values greater than 0. So like if you're thinking of this as y, right? When are my y values greater than 0? So we're graphing that, and then we're asking ourselves, I'm just going to repeat myself the way I wrote this. Where is the graph above the x-axis? Because that's where my answer is. So where's my graph above the x-axis? Describe it. Where is it?
It's a horizontal line.
Okay. What are the pieces that are above the horizontal line? Okay. Is it one piece? Is it two pieces? So we have that piece over there, over by -3, yes? And we have a piece over here by 4, yes?
Yep.
Those two pieces represent my solution. Because those two pieces are the pieces that are greater than 0. They are above the x-axis. Now, we're going to put our answer in interval notation. This right here. Where are these values that are above the x-axis in relation to -3? So in relation to the x value of -3, are they less than -3 or are they greater than -3? Okay, so we're talking, and that's the exact question we have to, because I'm hearing less than and greater than, because some of you are thinking in terms of x, which is what we need to be doing. Some of you are thinking in terms of y's. So this -3 is an x value, yes? So this piece of the graph is where in relation to x equals -3. So x equals -3 is represented by that orange dotted line I just drew. So where's my graph in relation? To the left. Okay, so the idea being here that part of my answer is x less than -3. And to keep in mind, as my graph, as my y values are getting bigger over here, it's going up and up and up. And as it's going up and up and up, it's also going farther left, left, left. And as it goes farther left, those x values are becoming smaller than -3. Am I making sense here?
Yeah.
Because that's always a tough part to grasp. It always is, every time. Now, we have another piece, yes? And now, this one is in reference to 4. So now you're asking yourself, is that graph, so the pieces that are above the x-axis, so the pieces that are greater than 0, So these have y values greater than 0, right? They have positive y values up here. Where is that in relation to 4? And if you think about 4 being a vertical line, that's my orange vertical line there. Where is it in relation to that vertical line? It is to the right of 4, which are x values greater than 4. Now, think about it. We've got these x values to the left of -3. We've got these x values to the right of 4. What kind of statement does this remind you of? The shading's going out, and so this reminds us of an or statement. Does it make sense that it might be an or statement? What was our original sign? It was greater than, yes? So it makes sense that it would be an or statement. Now, can you write that in interval notation? It is possible. Can you personally do it? Okay, so x less than -3. If a graph starts x less than -3, it starts where? In Mr. Stanley's room. Past Mr. Stanley's room, right? Negative infinity. Negative infinities always use parentheses. So it's like it's going this way. And then where's that interval stop at? -3. Parenthesis or bracket? And why are you guys saying parenthesis? Okay. If you go back to the original sign was just greater than. It was not equal to. So my values here are not going to be equal to. Good. Union sign. And then x greater than 4. Where's this interval start at? It's going to start at 4 with a parenthesis going off to positive infinity. Okay. Okay. Let's try another one. Now, and you will notice, before that previous example, we are solving quadratic inequalities, and we're in an algebraic type mode right now. We'll get to a graphic mode where we only use the calculator and graph it here in a moment, but I'm trying to talk about the algebra right now. So, as we look at this algebra, we're going to solve 2x squared plus 3x less than or equal to 20. Got a step 1 idea for me? Yeah, set it equal to 0. Which means right now it's not equal to 0, is it? What do we need to do? Subtract 20. So 2x squared plus 3x minus 20 is less than or equal to 0. And so then to actually work on finding our values we actually technically need to consider the equation. 2x squared plus 3x minus 20 equals 0. How do I solve this?
Do you want to do the product of AC?
Product of AC would be a valid answer. Okay. Guess and check for some people. Some people might try guess and check. Some of you might go quadratic formula. Product of AC is what I would suggest. So, can we review product of AC? I'm going to need a product of, I don't really have a lot of room. Product of what? 2 times negative 20. So product of negative 40 and a sum of 3. What multiplies to be negative 40 and adds to be 3?
That's a valid question.
I got an answer in my brain. I want you guys to answer it.
I'm thinking really hard. I feel like you should know this.
I feel like you all should know it. You're in pre-calc. I mean, it's just a matter of knowing our multiplication facts and running through them. So, what multiplies to be negative 40 and could add to be 3? 8 and 5 combo?
Yeah,
There we go.
Why are we all ignoring 8 times
Because
5?
it's Friday morning. I didn't eat breakfast. I'm really.
I mean,
I know.
It's
I
in
my
the
stomach
zero.
is really growling.
when I see something that ends in 0, I know it's even. I know it divides by 5 and 10. Like,
I mean, we knew. I
Okay.
the basic ones.
Give me another hour and a
okay,
half.
2x squared just drops down. 3x is going to split into some combination of 8 and 5. What do we need? Positive 8, negative 5?
Yeah.
So I'm going to say plus 8x minus 5x. I'm going to carry the negative 20 down, set it equal to 0. For terms, we split this equation in half. We split this in half. GCF of the first half. 2x squared and 8x both divide by 2x, leaving me with x plus 4 in parentheses. What about negative 5x minus 20? They both divide by what?
5.
Not just 5, but negative 5. Because if I factor out negative 5, I'm then left with x plus 4. 2 parentheses. The x plus 4 is in common, is our common factor. The 2x minus 5 are the other pieces. Set each part equal to 0. So x plus 4 equals 0. 2x minus 5 equals 0. Solve these. The obvious one is x equals negative 4. The other one is add 5, divide by 2, 5 halves.
Yeah.
What are these values?
X intercepts.
Okay, x-intercepts, zeros, where my graph crosses the x-axis, right? So these are going to be the numbers for my answer. We just have to figure out the whole less than, greater than business, yes? Now, if I sketch a graph over here, this parabola is a positive parabola, so it is opening upwards. I did not leave myself very much room, so this is going to be just that, a sketch. Okay. So what's my parabola doing? Did you graph it on your calculator? It's going through negative 4 and 5 halves, which 5 halves is 2.5. Looking something like that. Okay. I'm not being very precise here, but I'm really only putting the sketch in so you have something when you look back at this later, say, why was my answer what it is? You can reference the picture. That's the main reason I'm doing this. Now, what are we looking for here? What are we looking for?
That's a good answer.
Where is my graph less than or equal to 0, which means where is my graph? Where are values that are less than or equal to 0?
Left-hand side.
No.
Right-hand side.
How about, go with the basic here. In general, values that are less than or equal to 0 are going to be below the x-axis. Okay? If we want values that are less than or equal to 0, they're going to be below the x-axis. So what do we have below the x-axis this time? We have that bottom piece of the U, yes? And what do you notice about the bottom piece of the U? It starts at -4 and ends at 5/2. So if you think about those orange lines that I put in last time, where is that U? It is right there, isn't it?
Yeah.
So it goes from my values that are less than or equal to 0, in this case, go from -4 to 5/2. And so, as I write this answer, you can think of it as x greater than or equal to -4 or x less than or equal to 5/2. But realize this is a and statement. How are we expected to write an and statement?
Interval notation.
Well, and even before interval notation, if I'm talking inequality,
Compound inequality.
-4 less than or equal to x less than or equal to 5/2. Okay? Now, interval notation does go from -4 to 5/2. Parentheses or brackets. I kind of gave myself away because I already put equal to's on there, didn't I? Why did I put equal to's on there?
Keep us on our toes.
Because what was in the original problem, right? Okay, so this is brackets. Okay. I'm going to go with, I'm not going to officially start the next example because I'd be rushing it. But here, look, before you pack up, look at this next example with me. Based on the way we've done the last two examples, what do you notice if you start thinking about your first steps here? What do you notice about this next example?
Graph to find the x-intercepts.
Does x squared minus 4x plus 1 factor? It could quadratic formula, but it's not going to be, I mean, then you're going to get not fun decimals. When we have a calculator, yes? We're already graphing these to look at these. So these next ones, you're probably going to like in a way because we're going to skip the whole factoring thing. We're going to go straight to graphing them, and we're going to let the calculators tell me the x-intercepts, like what we did last week or earlier this week, whatever it was. So we're going to let the calculators tell us the x-intercepts, and then we'll be able to figure out our less than, greater than answer. Okay? So make sure you bring your graphing calculators with you next week.
I'll make sure.
Monday, we will finish these notes, and I would guess you'd have some work time. If I had to guess, homework will be due on Tuesday. Which, so if I have to guess right now, possibly Thursday test. Unless I get back and I start looking at lesson plans from last year and realize this test took a lot of extra review or something, but I would guess a Thursday test.